Good morning, boys and girls, and welcome to take two of this morning's video. I have a new camera mount, relatively new, and I just did this morning's video and noticed everything again was out of frame. My trademark, out of frame. Anyway, I've changed the angle of dangle on my camera mount, and we all know that the angle of dangle is proportional to the heat of the meat divided by the mass of the ass, but I digress. So, with this new angle of dangle in hand, let's get started. Welcome, boys and girls. Today, there's going to be more inventing things in the morning and more making stuff in the afternoon. This morning, you know, the other day I had that little green motor that was in that green boat, and I was thinking of a project for it, and I mentioned a canard, and a couple of people said, well, what do you mean canard? And this is what I mean canard, backwards. Actually, the word canard is from the French word for duck. Like this is a really strange duck. So anyway, there actually was a full-size canard that raced, it might have been in the 1980s. It was the Miss Circus U31. And it wasn't very successful. It didn't do that well. Although there are scale models of it that actually aren't bad. So years ago, I came across this canard plan. Now, I should have printed it a little larger. But anyway, so I have this basic plan, and this was based around a 4,000 milliamp and a 500 or 36 millimeter motor, so it was a bigger boat. But I brought it into AutoCAD and kind of sketched or drew over it, and so I could come up with dimensions and angles and kind of get an idea what I was working with and maybe make a set of plans. Actually, the first one followed his with a kind of a higher arc here, and then I lowered it down and changed things around. And this was based on a bigger motor, and this is based on a smaller motor, but still it's the Octura running gear. So that's how old some of these plans are. We're talking Fagau motors. Remember Fagau motors? That was a big deal back then. Anyway, so if any of you know of any decent plans for canards, I'd be interested in knowing. Now, here's something, because I've heard people have had issues getting a canard to corner. Here's what I'm thinking. This set of plans gives you a CG, and I stole that CG when I put my plans together. And here's what I'm thinking. What makes a rigger turn so good? It's because that hooked turn fin is right on this CG, and it's like walking down the street and grabbing a streetlight pole and just swinging around it and using that streetlight pole to change your direction. It's providing the centripetal acceleration, not centrifugal force. There is no such thing. But it provides the centripetal acceleration that draws you around the corner. Well, now these plans, if you look, show a turn fin at the very back of the sponson. I've seen other turn fins at the back of the front ski. I think the turn fin needs to be mounted right here on this CG, so you can grab that pole and do the centripetal acceleration, which you feel as a centrifugal force, but there is no such thing as centrifugal force. It doesn't exist. It's just the acceleration you feel. But I digress. So if any of you have any insight on canards, I might dedicate that green motor to a canard. So we shall see. Now, here's something I'm embarrassed to say. Not only do I have that green motor, I have a bunch of killer motors, just no commercial application to put them in. First, I have this. It's an 1120 1.5Y. This is 1500 RPM per volt. This would make a killer 8S all-out sawboat in a streamlined, bullet-shaped tub to take advantage of the small diameter and keep everything really light and just make it this really light bullet with little nothing bullet sponsons. It could be a killer, absolute killer 8S motor. This is an Aviox 1005 1.5Y, 5,500 RPM per volt. I had this in a pylon racer before. Water jackets, commercial water jackets will fit this thing. And I think I carbon wrapped this rotor. Back in the days, Steve and the gang were constantly taking Aviox motors apart and wrapping the rotors with either carbon or Kevlar until I don't know if Aviox ever started doing that. I do remember one. Now get a load of this. This is something I've never heard of before, but saw over at Steve's shop. You know how there's shrink tube? Well, there's also a product called shrink metal. It's horribly expensive, but Steve had one rotor where the magnets are essentially glued onto the rotor, and it had this shrink metal housing on it. It was uber cool back then. It was uber cool. This would make a killer little rigger motor. It would have to turn a small prop like a 27, a 427, but it would turn it at stupid high RPMs and be pretty quick. This is a Thunder Power 2040. It's about 3,700 RPM per volt. You could run it on 3S. It's about 250 watts continuous. With adequate cooling. You see, I put 2 cooling jackets on this thing. With adequate cooling, it could do quite well at 250 watts continuous. This little guy, now I don't recall the RPM per volt on this. It's an 1112 1.5 Delta, so it's probably in that 4,000 range, from 4,000 to 4,500, somewhere around there. Same thing for this guy. This is an 1112 1Y. This is a 1.5 Delta. They're going to be pretty similar in kV. I don't recall exactly what this was. I was going to run it in the Miss Madison, same thing as the T3, but the better part of common sense grabbed a hold of me and said, no, that motor has a better application. You're overpowering that. This, now get a load of this, boys and girls, and see what you think. See what you think. Somebody asked me if I've ever done a single motor driving 2 counter-rotating props. This would be the ideal candidate for it. This is a 1506 1Y S for smooth case, 5mm for 5mm shaft. This is 5,500 RPM per volt. This in an F5D airframe will easily do 200 miles an hour. Easily, all day long, without even thinking about it. I'm thinking about putting this in a small drag boat with enough battery, it'd have to be 2S, with enough battery to feed this thing 200 amps continuous. So I'd need big batteries of high C capacity in a small, lightweight boat. So the boat would be all battery and motor and everything else would be nothing. And then a set of gears. Now, I've been finding gears at a place called Stock Drive Products, SDP. Actually, it's called Stock Drive Products / Specialty Instruments or something like that. So it's SDP / SI. And search on there, and they have a lot of... that's where I get these uber cool Fairlock couplers. And they're not cheap, but they're super bitchin'. So back to this thing. It'd have to be lightweight gears driving 2 counter-rotating props, but this might make an uber cool drag boat. And here's what I would do. I wouldn't even bother cooling the motor. A drag boat runs from here to there. And so that's all it's going to do. It's not going to be doing laps. So for 30 seconds, this thing can build up heat, and then it can sit for 20 minutes and cool off, and then another 30 seconds. So cooling wouldn't really necessarily be that much of a consideration in a drag boat. Look at your AA fuel dragsters. Do they have a radiator? Why, no, they don't. Just thinking out loud. And then lastly is this little motor. Now this will have a really good application someplace. This is the 1107 1.5Y 4,500 RPM per volt, 4,400 H 3.2. The H is because it's a helicopter motor. If you look, it's the same motor casing as this, except it has this finned aluminum, what would you call it, skin on it. And then over the skin is a housing. In here is a centrifugal fan, like you'd find in a vacuum cleaner. And so it draws air in here and blows it across these fins and through the motor itself. So the cooling is pretty efficient on them. They do a good job. So there's that little guy that doesn't have a home. This would power a 3S rigger that would be stupid fast. I mean, absolutely stupid fast at 4,400 RPM per volt on 3S, and it could do it. I mean, this motor on 2S has no problem pushing 38 millimeter props. I mean, Steve's motors are torquey and have a high KV. I mean, his motors are really efficient. I like his motors. Can you tell? It's just that these don't have a really dedicated use yet. We'll have to find out. So there you go, boys and girls. This morning, inventing. The mailman comes this afternoon. I'll have parts to finish the electric boat stand. There's actually a secret feature on the electric boat stand I have not shown you yet. So when the electric boat stand is complete, I will show you how that works. Also coming in today's mail is a new battery for my transmitter. So hopefully next week I do have some perk tests scheduled. I don't know what day. We'll have to see. But hopefully next week we'll get to the pond and we'll run the, what do we have in there? We have the Cobra M450 and we have the T3. The T3 that'll be its final run before going into the paint shop. I shouldn't say final run. Where's some wood? Where's some wood? The next run of the T3 before it goes into the paint shop. Until then, boys and girls, jet out. Good morning, boys and girls, and welcome back. I've been inventing things, and I've come up with a dilemma, a thought. How's it going to work? I talked about the CG being, your turn fin being on the CG to give you maximum acceleration around a corner. Well, that's true. And that's exactly what we're going to try to do. But now let's examine a conventional rigger. The CG is right here on this turn fin. And it's riding on 3 points. It's riding on the end of 2 sponsons, and it's riding on the rudder. Or not the rudder, the propeller. And the rudder and the propeller are really in close proximity. So it's riding on these 2 sponsons, and the steering end is right at one of the ride surfaces. So as you're going through the corner, this ride surface is essentially staying in the direction of travel. Everything is, and this hook is pulling it around, so everything is staying in the direction of travel. That's what you want to achieve. You don't want it sliding out and such. So looking at this, if I have steering back here, the center of balance, the turn fin, here, and I give it full rudder, it's going to swing around this turn fin, but it's going to drag this front ski through the water sideways. Because the boat's going backwards and it's turning about this. The front of the boat is turning faster than everything else. So I've got a force this way, and I've got this thing counteracting. It's like I had a rudder up in the front, and it's going backwards. You follow what I'm saying? You picking up what I'm putting down? You follow that? So, here's something I've never seen, and it's probably because of the mechanics of it, but using modern RC car technology, I'm sure there's something available that would work. Why not? Since you're riding on 3 points, you're riding on the back of this sponson, the back of this sponson, and the back of this ski. And the prop is neither lifting nor sinking because it's right on your ride surface. It's there. It's not raising your ride surface. It's not lowering your ride surface. Ideally, you'd want this set up to where there's no lift, no sink. It's neutral, which would mean if this front ski were in fact your rudder, and maybe you could put a fin behind the ski and articulate the ski. You follow what I'm saying? So the whole ski would be on a shaft with some camber to it. And that whole ski would rotate. That way, as the ski turned into a turn, it would lean into that turn, and that may be the way to get a canard to go around a corner. What do you guys think of that line of thinking? Could it be that's the way to make a canard work? So think about it. You'd have this doesn't exist. You'd have your sponsons here, and up front you'd have something that would steer it. Not only turn, but carve like a ski would carve. What do you guys think? Jet out. Oh my, boys and girls, we are inventing things right and left. We're looking at plans, and we're thinking of steerable skis, and we're cutting out paper, and we're looking at ideas, and all of a sudden it dawned on us. This is a ski, right? Why not make something like a slalom ski? Now follow me. You see where the motor is here? What's in front of the motor is unnecessary. The battery's back here to get the CG back here. This whole thing up here is only there to hold that ski. What if you made a little ground effect airplane, and instead of all this sticking out the nose, you merely had a carbon fiber boom, and inside that carbon fiber boom was another carbon fiber boom attached to your slalom ski that would be out in front, and then you could carve corners in your little ground effect airplane that would have just this carbon fiber tube going out in the front with a ski that would carve. And it would whip around a corner, and that turn fin would hook those sponsons in, and that little sucker would whip around a corner. What do you guys think? A slalom ski. Yeah, I use it for mixing JB Weld. But, depending on where you put this, you might want to put it back here in the back to get that. Ooh, I like that. Oh, yeah. That could work really well. What do you guys think, huh? For steering, instead of a rudder, have an articulated ski. And the mechanics of it are nothing. It's a rotating push rod inside of a carbon fiber rod, and the bell crank could actually come out the back, and you wouldn't have to worry about waterproofing it. your control arm would be in the back and somehow a servo would actuate it. But what do you guys think? What do you guys think? That could be cool. Until next time, boys and girls, jet out.